section 3 has us solving polynomial equations that are x squareds or higher, and specifically x cubes, that we don't have a GCF for. So before we do that, we need to talk about one more kind of factoring called the sum and difference of cubes. So just a quick reminder to you about what a cube is. I listed the first couple there for you just so you can recognize them. It is important when you look at numbers like these on the right-hand side that you see them as cubes. You can get a 1 by cubing 1. You can get an 8 by cubing 2, and so on. There are cubes after that, obviously, but they're not as popular, so these are probably the ones that you want to know. There are formulas for the sum and difference of cubes. I'll be honest with you, you could memorize the formulas, but I tend to show students a shortcut, something that I remember to factor these. But again, if you'd like to memorize the formulas, that's certainly up to you. They include A's and B's, but it looks kind of complicated, so you can make the choice based on whatever you prefer. So they're going to ask you to factor them. Every time you factor a sum and difference of cubes, it'll break up into a 2 by 3. You always copy the sign, turn it a little opposite, always end positive. All right, so first thing you need to do is take the cubed root of the first term. The cubed root of x cubed is x, and then you square it. Take the cubed root of the second term. The cubed root of 216 is 6. If you need help learning how to do that on the calculator, please let me know. If not, you can consult the list that's on this screen right now. At the bottom you can see 216 is 6 cubed, so the cubed root of 216 is 6. And then all the way at the end, you square it. In the middle, you take the product of those two and write it down. That's how you can factor the sum and difference of cubes. So let me show you again in number 2. Always a 2 by 3. The cubed root of x cubed, oh, just kidding, I got ahead of myself. Copy the sign, turn it a little opposite, always end positive. When I say turn it a little opposite, I mean whatever you started with, you need the opposite sign. All right, the cubed root of x cubed is x, then square it. The cubed root of 27 is 3, then square it. Put the product of x and 3, 3x, in the middle. Gets a little trickier when you have numbers and letters, but the same thing. A 2 by 3. Copy the sign, turn it a little opposite, always end positive. All right, careful with the first one. The cubed root of 8a cubed is a 2a. And if I square a 2 and an a, I get 4a squared. The cubed root of 125 is 5, and if I square it, I get 25. The product of a 2a and 5 is 10a and goes in the middle. Last one together. 2 by 3. Copy the sign, turn it a little opposite, always end positive. The cubed root of 64x cubed is 4x. And if I square 4 and an x, I get 16x squared. The cubed root of 1 is 1, and if I square it, I get 1. The product of 4x and 1 is 4x and goes in the middle. Pause the video to complete the you try it's. So the only other thing they're going to ask you to do is to solve by factoring. So you cannot do anything in this question, number 1, like adding 64 and cube rooting, because you're going to lose answers. If you add 64 and cube root, you'll get 1 answer, you'll get 4, but we know because this is a cubic, you should have 3 roots, 3 solutions. So start by factoring. If I factor, I copy the sign, turn it a little opposite, always end positive. The cubed root of x cubed is x, and then I square it. The cubed root of 64 is 4, and then I square it. The product of x and 4, 4x, goes in the middle. The first root that comes out of a cubic is super easy for you. This factor out front gives me a root of 4. I tend to do that first, box it, and keep it to the side. It's this second part. Oops, it's not what I wanted to do. It's the second part that's trickier for you. You can't factor it. You don't know two numbers that multiply to 16 and add to 4. So instead, the only other way to solve this quadratic is the quadratic formula. My a value is 1, my b value is 4, and my c value is 16. So I get x equals negative b means negative 4 plus or minus the square root of b squared, 4 squared is 16, minus 4 times a, which is 1, and c, which is 16, all over 2 times a, which is 1. Look up the quadratic formula if you need to. So if I pretty this up, I get negative 4 plus or minus the square root of 16 minus 64. You can type that right into the calculator the way that you see it. The calculators in class or their blue equivalent actually do a really good job of that for you. So if you type it in just the way you see it, you end up with a negative number. So take a second, make sure you're okay with that. 16 minus 4 times 1 times 16, you end up with a negative 48. So I'm going to deal with this negative 48 to the side for a second. The square root of negative 48. The reason you couldn't factor that quadratic in the beginning is because it's imaginary, it's complex. If you birthday cake or use the calculator to simplify the square root of 48, you get 4 root 3. Well, it's going to be 4 root 3i, or if you want to see it this way, maybe I'll write it that way to be a little bit more clear. It's an I. It's complex. I talked about the discriminant earlier. It's a complex answer. And so if I replace it, an uncommon denominator, just like we did in section 7, chapter 4, we get 4 over 2 plus or minus 4i root 3 over 2. And then all you need to do is reduce. I get x equals negative 2 plus or minus 2i root 3. That's it. So I boxed one of the answers in the beginning in black, and there are 2 answers boxed in purple. That gives me the 3 roots I intended to get in the first place. Number 2, I'm going to do the same thing. I'm going to start by factoring. This breaks up into a 2 by 3. Copy the sign, turn it a little opposite, always end positive. The cubed root of 27 is 3, squared is 9. The cubed root of y cubed is y, squared is y squared. And the product of 3y goes in the middle. First factor looks a little funny, but it's still going to follow the same rules. The root is negative 3. Be really careful when doing the quadratic formula on the quadratic that's left. It's out of order. A is actually 1, B is negative 3, and C is 9. Take a second and look at that. All of those numbers are out of order. So I start. I'm going to do y equals. Even though you're used to writing x equals, these variables here are a y. Y equals negative 3, negative b, plus or minus the square root of. Negative 3 in parentheses squared is 9, minus 4 times 1 times 9, all over 2 times 1. Take a second, make sure you're okay. So I get positive 3 plus or minus the square root of. Plug that into the calculator the way you see it. You should end up with negative 27, and on the bottom 2 times 1 is 2. The square root of negative 27, when simplified, gives you 3i root 3. So what I really have here is y equals 3 halves plus or minus 3i root 3 over 2. And that's it. Those are the 2 answers I was looking for. One more. First thing you need to do is set it equal to 0. So I'm going to do that by subtracting 125 from both sides. That leaves me with x cubed minus 125 equals 0. And once it equals 0, you're more than welcome to factor it like we've been doing. This breaks up into a 2 by 3. Copy the sign, turn it a little opposite, always end positive. The cubed root of x cubed is x, and then I square it. The cubed root of 125 is 5. and then I square it. And the product of x and 5, 5x, goes in the middle. This first root is super simple. It's just positive 5. Box it and call it a day. It's the second set that's a little bit more challenging. So my a value is 1, my b value is 5, and my c value is 25. All right, x equals negative b, negative 5, plus or minus the square root of b squared means 5 squared, which is 25, minus 4 times a, which is 1, and c, which is 25, all over 2 times a, which is 1. So I get x equals negative 5 plus or minus the square root of. Type that right into the calculator the way you see it. 25 minus 4 times 1 times 25 should give you negative 75 all over 2. The square root of negative 75, if simplified on the calculator, remember, don't put that negative underneath. That won't allow you to do anything. You should end up with 5i root 3. So if I uncommon denominator and simplify, I get negative 5 over 2 plus or minus 5i root 3 over 2. I can't reduce, so I'm all done. There are the 3 roots I anticipated with the cubic. Pause the video to do the you try it. Just be really careful. The computer's doing this really weird thing where the eyes are disappearing. I'm not sure why that's happening. In the second you try it, something interesting is happening that hasn't occurred yet again today, but we had it earlier this year. Don't forget that anytime you have a coefficient in front, you have to do constant over coefficient. So that first root is a negative 1/2. And don't forget we have a wrap up. Today we factored the blank and blank of cubes to solve a polynomial equation. That is the sum and difference of cubes.